Calculus differentiation. The process of finding the derivative of a function is called differentiation. The function is differentiable at x if its derivative exists at x, and differentiable on an open interval a, b if it's differentiable at every point in the interval. The common notation used to denote the derivative of y equal to f of x is 1. F prime of x, 2. dy dx, 3. d f of x dx. The notation dy dx is read as the derivative of y with respect to x. If y equal to f of x is any curve, then dy dx or f prime of x defines the gradient of the curve at any point x, y on the curve. If y equal to ax to the power n, where a is a real number, then dy dx is equal to n ax to the power n minus 1. So when you are given y equal to ax to the power n, you have to multiply the n times the coefficient a of x to the power n and then subtract the power n minus 1. Application of differentiation. The equation of the tangent and the normal. Consider the diagram. So if you have that tangent, that line which is touching the curve, and the perpendicular line, which is that one, which is at right angles, that line which is perpendicular to the tangent is what is known as the normal. If y equal to f of x is the equation of any curve, then dy dx is the gradient of the tangent at any point on the curve. The gradient of the tangent at a point a which is x, y, is the value of dy dx. Therefore, the equation of the tangent is y minus y1 equal to dy dx, which is representing the gradient. Open your bracket, x minus x1. The normal is the line perpendicular to the tangent. So it is the line which is at right angle with the tangent. The gradient of the tangent is dy dx. So the gradient of the normal is negative 1 dy dx. Therefore, the equation of the normal is y minus y1 equal to negative 1 dy dx. Open your bracket, x minus x1. Let's look at some examples. Question 1. Find the equations of the tangent and the normal to the curve y equal to x squared minus 2x minus 3 at the point where the curve meets the positive x-axis. Find the equations of the tangent and the normal to the curve y equal to x squared minus 2x minus 3 at the point where the curve meets the positive x-axis. Now, when you look at the equation of that curve, it is a quadratic expression, and the value of y on the x-axis is a 0. So what we are going to do is to say x squared minus 2x minus 3 is equal to 0 because the line x-axis is the same as y equal to 0. So what we are supposed to do is to find two integers such that when we multiply them together, they'll give us a negative 3, but when we add them, they'll give us a negative 2. And then we'll replace them where there's a negative 2x. So we are going to say x squared plus x minus 3x minus 3 equal to 0. Then we'll factorize by grouping the terms, which is going to give us x plus 1 and x minus 3 equal to 0. So we'll get the first factor, which is x plus 1, and equate it to 0. And we'll get x minus 3 and equate it to 0. So our first value of x will be x equal to -1, and our second value of x will be x equal to a +3. Now the question is saying, find the equations of the tangent and the normal to the curve at the point where the curve meets the positive x-axis. So we'll get the value of x equal to 3 because it is a positive. So from there, we are going to get the gradient of the tangent, which is the derivative of the equation to the curve. So we are going to say y equal to x squared minus 2x minus 3. Our dy dx will be, we are going to multiply the power 2 times the coefficient 1, which is there. So 2 times 1 will give us a 2. Subtract 2 minus 1, and then here there's the power 1. We'll multiply 1 times -2, which will give us a -2. Subtract 1 minus 1, we'll get a 0. Any base to the power 0 is the same as 1. So when you multiply 1 times -2, you get a -2. So our dy dx will be equal to 2x minus 2. When x equal to 3, where there's that x, will replace our 3. So we are going to say 2 times 3 will give us a 6. 6 minus 2 will give us a 4. Our gradient will be a 4. So the equation of the tangent is given by y minus y1 equal to dy dx, open your bracket, x minus x1. Where there's dy dx, we are going to substitute a 4. Since the tangent was at the point 3, 0, where there's this y1, we are going to replace a 0, and where there's x1, we'll replace our 3. So we are going to say the positive x-axis is 3, 0. Where there's the y1, we'll replace a 0. Where there's x1, we'll replace a 3, and then we'll expand. 4 times x will give us a 4x. 4 times -3 will give us a -12. Therefore, the equation of the tangent was y equal to 4x minus 12. Now, when you multiply the gradient of the tangent times the gradient of the normal, you are supposed to get a -1. So we are going to say the equation of the normal is given by y minus y1 equal to -1 over dy dx, open your bracket, x minus x1. So where there's that dy dx, we'll replace our 4. Where there's y1, we'll replace our 0. And where there's x1, we'll replace our 3. It will look like that. From there, we'll expand. We'll say -1 over 4 times x will give us a -1 over 4x. -1 over 4 times -3 will give us a positive 3 over 4. It will look like that. Since we have a common denominator, which is a 4, we can always cross multiply. So the equation of the normal is therefore 4y equal to -x plus 3. 2017. Find the coordinates of the points on the curve y equal to 2x to the power 3 minus 3x squared minus 36x minus 3, where the gradient is a 0. Now the gradient is the same as getting the derivative, so we are going to say dy dx of 2x cubed minus 3x squared minus 36x minus 3. So we are going to say y equal to 2x to the power 3 minus 3x squared minus 36x minus 3. Then we'll have to find dy dx because that is representing our gradient. Dy dx of y equal to 2x to the power 3 minus 3x squared minus 36x is the same as multiply that power 3 times 2 will give us a 6. Subtract 3 minus 1 will give us a 2. So 2x to the power 3 will give us 6x squared. Multiply 2 times a negative 3, it will give us a negative 6. Subtract 2 minus 1, we'll get a 1. So we'll get a negative 6x. 36, negative 36 times 1. 1 times our negative 36 will give us a negative 36. 1 minus 1 will give us a 0. Any base to the power 0 is the same as 1. So 1 times negative 36 will give us a negative 36. Now 6x squared minus 6x minus 36 has a common factor, which is a 6. So we can always multiply the whole of this equation by 1 over 6. It will reduce to x squared minus x minus 6. Since the question is saying where the gradient is 0, where there's dy dx, we'll replace our 0. This one is a quadratic expression. So we'll say x squared minus x minus 6 is equal to 0. Then we have to find two integers such that when we multiply them, they'll give us a negative 6. But when we add them, will give us a negative 1. And then we'll replace them where there's that negative x. So we are going to say x squared plus 2x minus 3x minus 6 equal to 0. Factorize by grouping terms. We'll get x, open our brackets, x plus 2, close your bracket, minus common factor, negative 3, open your bracket, x plus 2, close your bracket. We'll group x minus 3 and get the common factor, x plus 2. So from there, what we are going to do is to equate x plus 2 to 0 and x minus 3 to 0. Therefore, our x will be equal to negative 2 and our x will be equal to a positive 3. 2018. Find the equation of the normal to the curve y equal to x plus 4 over x at the point where x equal to 4. So to find the equation of the normal, we'll have to find the gradient of the tangent first. So we are going to say y equal to x plus 4 over x. We are going to change that denominator x into a negative index by putting a negative 1. So 4 over x is the same as 4x to the power negative 1. Then to find our dy dx, we are going to multiply our power 1 times our coefficient 1, and then we'll subtract 1 minus 1 here, which is going to give us a 0. X to the power 0 is the same as 1. 1 times 1 will give us a 1. And then we'll multiply negative 1 times our positive 4, which will give us a negative 4. Subtract negative 1 minus 1, that will give us a negative 2. So our dy dx will be 1 minus 4x to the power negative 2, which is equal to 1 minus 4 over x squared. When x equal to 4, where there's that x, we are going to replace a 4, which is going to give us 1 minus 4 over 4 squared, which is the same as 1 over 4. 4 squared is the same as 16. 4 into 4 is 1. 4 into 16 is a 4. We'll solve that as a common fraction. 1 is the same as 1 over 1. Common denominator 4. 1 into 4 is a 4. 4 times 1 is a 4. 4 into 4 is a 1. 1 times negative 1 is a negative 1. 4 minus 1 will give us a 3 numerator. So that's going to give us 3 over 4 gradient of the tangent. Now the question is saying find the equation of the normal to the curve. So what we are supposed to find is the equation of the normal. We are going to say y equal to x plus 4 over x to find the value of y, we are going to replace the value of x, which is a 4, into the original equation to solve for y. So we are going to say y equal to 4 plus 4 over 4. 4 over 4 will give us a 1. 4 plus 1 will give us a 5. So the value of y at the point where x was 4 was a 5. Then the equation of the normal is y minus y1 equal to negative 1 dy dx, open your bracket, x minus x1. So where there's this y1, we'll replace a 5, and where there's that x1, we'll substitute a 4. Where there's dy dx, we'll replace our 3 over 4. It will look like that. Negative 1 divided by 3 over 4 is the same as a negative 4 over 3. So from there, we'll expand. Negative 4 over 3 times x will give us a negative 4 over 3x. Negative 4 over 3 times a negative 4 will give us a positive 16 over 3. We'll move the negative 5 from the left to the right. It will become a positive. It will look like that. We'll solve 16 over 3 and a positive 5. Since they are common factors, they can be simplified as a fraction. Our 5 is the same as 5 over 1. Common denominator 3. 3 into 3 will give us a 1. 1 times 16 will give us a 16. 1 into 3 will give us a 3. 3 times 5 will give us a 15. When you add 16 plus 15, you get a 31. It will look like that. Since we have a common denominator 3, we can always cross multiply. Our equation will be therefore 3y equal to negative 4x plus 31. 2019. Find the equation of the tangent to the curve y equal to, open your bracket, 2x plus 3, close your bracket, to the power 3, at the point where x equal to negative 1. So we are going to say y equal to 2x plus 3 to the power 3, and then we use the chain rule. We are going to say let u equal to 2x plus 3. Then our y will be equal to u to the power 3. We'll find dy du, which is going to give us 3u squared. And then we'll find our du dx after u equal to 2x plus 3, which is going to give us a 2. Our dy dx will be dy du times du dx, and then we are going to replace. Where there's our dy du, we'll replace our 3u squared, and where there's our du dx, we'll replace our 2. It's going to look like that. Where there's that u, we are going to substitute our 2x plus 3, which is going to look like that. So our dy dx will be equal to 3. Open your bracket, 2x plus 3 to the power 2 times 2. Now when x is equal to negative 1, we are going to say our dy dx is equal to 3, open your bracket, 2, where there's x, will replace our negative 1. 2 times negative 1 will give us a negative 2. We'll solve what is in the brackets first. Negative 2 plus 3 will give us a positive 1. So we are going to have a 1 squared. So we'll multiply 3 times 1 times 2, which is going to give us a 6. Therefore, the gradient was 6. From here, we are supposed to find the value of y where x was negative 1. So we are going to say y equal to, open your brackets, 2x plus 3 to the power 3. When x equal to negative 1, we are going to get 2 times negative 1 plus 3 to the power 3, which is giving us a positive 1 to the power 3. If we multiply 1 by itself 3 times, we'll get a 1. Our y will be equal to 1. From here, we can find the equation of the tangent. We are going to say equation of the tangent is equal to or is the same as y minus y1 equal to dy dx, open your bracket, x minus x1. Where there's y1, we'll replace our positive 1. Where there's our dy dx, which is the gradient, we'll replace our 6. And where there's our x1, we'll replace our negative 1. It will look like that. And then we'll expand. So we'll multiply 6 times x, which will give us a 6x. 6 times positive 1 will give us a positive 6. We'll move our negative 1 from the left to the right. It will become a positive. So we are going to say y equal to 6x plus 6 plus 1. When we add 6 plus 1, we are getting a 7. Therefore, the equation of the tangent to the curve was y equal to 6x plus 7. As simple as that.